Hi, this is Miss Linton, and we are going to review Chapter 34, Digestive Systems and Nutrition. Everybody say hey.
Hey.
All right. Okay. Guys, didn't I just do this? Are you all right?
Yeah.
What's wrong? What do you see?
There's a slide with a squid on it.
Oh, okay. All right. I'm sorry. All right. So, we're going to study different systems. Didn't we just do this yesterday?
Yeah.
Okay, so we can go pretty fast then, right? Okay, let's go super fast. Okay, repeat after me. Watch. Look. Boys. Ingestion. Do it. Ingestion. Digestion.
Digestion.
Absorption.
Absorption.
Egestion.
Egestion.
Okay, do it one more time. Ready? Here we go. Do it together. It's fun. You'll remember forever.
Ingestion.
No, it's darn it. Here we go. Ingestion, digestion, absorption, egestion. Perfect. Okay, moving on. So we said extracellular, intracellular. Which one's better? Extracellular, because it's more efficient. Put all your enzymes in a tube, digest and absorb when properly, instead of having to completely continue to do phagocytosis and bring it in. We looked at an incomplete tract. Did a little summary of an incomplete tract there if you want to know. And then we looked at a complete digestive tract, which is more efficient. Complete digestive tract, because there's an indoor and a outdoor. And so you can have specialization along the pathway. Yay! Continuous or discontinuous? Which one's better?
Discontinuous.
Now, all of their different ways are adaptive just for them, right? So better is a bad term. Which one is evolutionarily more advanced? Discontinuous, and that allows us to do other things with our time besides constantly feeding. If you're going to have discontinuous feeding, though, you have to have a what? Yeah, some storage facility, right? We talked about different strategies, food that you eat, and that you can tell what kind of organism you are by two different things. What are the two different things you can look at to determine?
The length of your digestive.
And your
teeth.
Okay, so teeth will tell you a lot of information, and the length of your digestive system. And we know if you have really long intestines, you're probably eating, or lots of stomachs, you're probably eating what? Plant material, because it's so hard to digest. What enzyme do we lack? Cellulase. Yeah, to digest cellulose. Good. So then we went on and looked at the human digestive system. Every place has something special that can happen at it. So let's see if we can break it down just from memory. Let's build it together, shall we? So where's the first place that we're going to start? Where's stop number one? Mouth. Okay. What kind of digestion takes place in the mouth?
Mechanical and chemical.
Mechanical using what? Teeth. And chemical, amylase, salivary amylase. And what does it break down? Carbs, starch, yeah. Usually into something like maltose, which would eventually taste sweet. Okay? Now, once it leaves our mouth, where are we going to next? What's number two? Yes. How do we make sure food goes down the esophagus and not our trachea? Yeah, epiglottis covers the glottis of the trachea, right? And then when we think about the esophagus, how do we move food through the esophagus? Is it gravity?
Oh, it's the
Muscles.
Yeah, what's that called?
It starts with a P?
Yes, it does start with a P.
Peristalsis.
Yes, peristalsis. Those are the wave-like contractions of your esophagus. Now, where do we go next?
The stomach.
The stomach. Stop. I should stop. How do we get food to go from the esophagus and its wave-like contractions into the stomach?
There's a
Sphincter. Yeah. Okay, you have a sphincter. And what opens up that sphincter so food can get in? Peristalsis. Good. Okay, what kind of digestion occurs in the stomach? Mechanical using muscles. Okay, and you said chemical using what? Pepsin.
Which breaks down proteins.
Plus HCl, right? And what does that break down?
proteins.
Proteins. how do we protect the stomach from these acids?
Lining.
Mucus. Who secretes the mucus?
Liver here. Oh,
Pyloric
Yeah.
gland. Remember mucus pie, grossest pie of all?
okay.
Mucus pie. Okay, good. How do we store the pepsin when it digests proteins? An inactive precursor called pepsinogen, a zymogen, an inactive precursor. And hydrochloric acid is what converts pepsinogen into pepsin. Yes,
Oh, what produces the mucus?
pyloric glands. Gastric gland secretes pepsin and hydrochloric acid. You good? All right. We are ready to leave the stomach. We're going to go out of sphincter again. Where are we going next?
The small intestine.
Yes. Now, the small intestines, it's not just the small intestines, but there are other things that secrete into the small intestines that are secreting in there. What are the other two things?
The duodenum? Oh, like, okay.
Liver and the pancreas. Good. All right. So what does the liver make?
Bile.
Bile. What does bile do? Emulsify fat. So it's like a chemical mechanical digestion. Using chemicals to mechanically break up fat. That's emulsification, which is going to increase the surface area. So when we have an enzyme like, lipase, that the pancreas secretes, you can actually chemically break down the fat because you've increased the surface area due to bile. How do you feel about that? Good? Yes?
So the lipase helps emulsify the fat?
Yeah, it's kind of like this. Okay, so what bile does is it will take these sections. Did you see that I drew them separately? It takes these sections and breaks them apart from each other.
Lipase.
No. Bile does that. It emulsifies it, breaks the chunks up, and that increases then. Imagine these were farther apart from each other, which is what I was trying to show you. Then now we have more surface area for the lipase to work on to actually digest them.
Okay.
Okay.
It does what your teeth do mechanically, it does chemically. It chemically breaks up the fat into smaller pieces and chunks of fat so that you increase the surface area for the lipase to work on it. Now, do we feel good?
Yes.
Really tried hard to make that work. Okay. Okay, Papa. All right, go away. All right, now, okay, so that bile, liver, now we know the liver does other things. What else does the liver do? Besides producing bile, what else does it produce?
Plasma proteins.
And urea, right? What else does it do? It destroys red blood cells. Do you remember this part?
Oh yeah, that's what you're.
Yeah, remember how it'll do the glucose glycogen thing, right? It'll store vitamins. Detoxifies. So this isn't really anything to do with digestion, it's just stuff that the liver does. You have that whole slide. Remember that colored slide? I put 4 different colors on it. That's that slide. That's kind of messy. All right. Yes, I would like to continue. Did it keep recording? Yeah? All right. Such an ugly drawing. Okay, pancreas. There are 3 different categories of enzyme. One is lipase. What's another one?
Trypsin.
Trypsin and chymotrypsin. And both of these things do what? Work on protein. Okay, and then you also have another amylase that works on carbs and starch. Then your small intestines, they finish the job. They get everything done, and then that's where all the absorption takes place. That's not a very good picture. If I was going to take a picture, I would take a picture of that. It's much, much neater, right? And it kind of spells everything out. Okay, so can you follow that all through? Mouth, carbs, salivary amylase, maltose, stomach, protein, pepsin. Pepsinogen, an active precursor, breaks it down to polypeptides. Both the pancreas and the liver secrete into the small intestines. That's why I have the small intestines off to the side. Starch, pancreatic amylase to maltose, polypeptides, trypsin, chymotrypsin into peptides, fats, lipase, glycerol, and fatty acids. Who broke up the fat? The liver making bile, which emulsifies it. Small intestines then are going to take care of the maltose and the sucrose and lactose and these peptides. They're going to break it down individual amino acids, the building blocks. And then you have all absorption taking place. Okay, and we talked about, in addition to that, I'm good on that, low pH. One important thing is that low pH coming into the small intestines is counterbalanced. Somewhere in here I have like the pancreas secreting, pancreas secreting sodium bicarbonate, remember that? Otherwise your stomach acid would burn your intestines. And here's that slide about the liver, remember this?
Mm-hmm.
So that's a good one, showing all the different liver functions. Okay, key thing about the small intestines is we know it's good for absorption, okay, and because it has a lot of surface area, and those are folds on folds on folds, that's a structure function thing, right, for absorption. And then we can see how things like both the pancreas and the liver are secreting things into the small intestine, which then the small intestines finishes it off, and then you have absorption. I want to bring in about fats, right, going into the lacteals in the middle of the microvilli of the small intestine. Things can go wrong. You can get ulcers. You can get polyps. You can get stuck, okay? You have to work on ways to get that out. This was a little experiment to show you how specific that you needed particular pH to work with your enzymes. And then we just finished off by talking about, and I have practice problems that we didn't do, and then we can do now, just about, we have macronutrients and micronutrients, just like plants have macronutrients and micronutrients, things they need in bulk, and some they need less of, but it's really important, because your vitamins and minerals are often parts of enzymes. Okay, let's go through and do all the practice problems that we can find. I'm looking. If you see one, just tell me. And okay then. Okay, Papa. It's from a movie. Do you know what movie it's from? Do I not have a single practice? Where are they? Here's some. You know what movie that's from? It's like BC1.
Apparently I do.
You know where it's from? Okay, Papa. Sorry, it's Friday. Jeannie's already out. Okay, let's log in as our favorite cookie. And I'm going to pause you while we do a little work, and then I'll turn you back on. So before I go over the answers, I just want to add in one thing. We forgot to talk about the large intestine. What does the large intestine do for us? Water absorption. The small intestine does too. So I don't really know which one I marked for that answer because I just went through this question. Because the small intestine absorbs water too, but we think about the large intestine as its role is to absorb water and to make what? Vitamins. And it's not that the large intestines are actually making the vitamins, but they're providing a home for what? Bacteria who make the vitamins, right? Okay, I have some leftover names here from last class, so are all of you guys done?
Yes.
Okay, here we go.
Oh, that's
Yay! None of these right, because what was the right answer?
The mouth.
Mouth. Good.
which breaks down the starch.
Yes. Yay! Microvilli, increased surface area for nutrient absorption. Right. Protein digestion will not take place. Not fat, right? Fat digestion, it's emulsified by bile from the liver, and it is actually digested by lipase from the pancreas. 4, yes, so good. We went with large intestine. Definitely not gallbladder. That's not even one I would have done. at all.
We,
If I was gonna pick a alternative one, I would have picked A, okay? Definitely not C. All right, and great. Yeah, esophagus doesn't digest anything, so you should have been like, no. And, yeah.
we picked the.
No one
Oh.
got
Yeah, we did it wrong.
I did it with her, and I picked the correct one. I'm all, it's only this one. I didn't read it. It's important to read your questions, especially when I'm the one who wrote them, yes.
it. No one got it right.
Or the both right.
Never seen that one.
For D,
Yes.
cirrhosis.
Yeah, now, I didn't go into the health like
Yeah.
we had to, because we don't have to, but that was in there because I had it from in there previously.
And
So don't stress out about that at all. Don't stress out about that question, okay? I don't, this used to have a thing that I would hit play and then it would move around, but when I updated it, doesn't.
You're gonna put the semi-green, the semi-green screen.
No, yeah, the semi-green. Yeah, that's it. Okay, the end. Good job. Yay! Oh, did I unrecord it? Yeah, okay, I did. Okay, have a piece of toast. That's a carbohydrate. In fact, while you're having the piece of toast, let's talk about how it will get digested. Because I always say have a piece of toast. What will digest it first?
The mouth.
Mouth using teeth will mechanically digest your toast, right? And then what will work on that toast after?
The amylase in the mouth.
Salivary amylase will break it down. It'll move into the esophagus. It'll move into the stomach where it'll get what kind? Mechanically digested. Then it'll move into the small intestines where bile will emulsify the fat of the butter, right? And then the pancreas will secrete lipase to completely digest the butter, right? And then the pancreatic amylase will break it down further, and then the small intestines will break it down further, and then it'll get absorbed. So have that piece of toast. You love it. Okay, bye. Say goodbye.
Bye.
All right.